Good morning. It's 2:30 p.m., but I'm just getting started now. I guess that's not too surprising. I have my tea. I already had a coffee. So, Tom Nook says hi. We're going to start with Erlang soon. You can skip ahead if you're seeing this after the stream because I'll probably have chapters. I usually put that in there. Um, Yeah, so Erlang is a programming language that was made in 1986 by Ericsson, a phone company in Sweden. Does a lot of like parallel processing stuff and highly reliable and self-healing and all that kind of stuff. WhatsApp and Discord uses it along with Rust for the fast functions. Um, and I've been programming in Elixir, which is on the same virtual machine. Just like there's a whole bunch of, languages on the Java virtual machine JVM. I think Scala and Kotlin are both on it, right? I don't know what else is on it. Um, we've been reading from a book called Learn You Some Erlang for Great Good by, who's the person who wrote this? Come on. You would think like they would have their name on the main page, right? Let's go to this page. Okay, it's by Fred Hébert. I guess they're a French person. But there's an online book you can read for free on the URL learnyousomeerlang.com. I think I have the links in my older videos. You can look at a playlist. I'll probably have the link in the description soon for all the previous videos we did on Erlang. We're just kind of following the book chapter by chapter. So that's kind of where we are. I got quite a bit done yesterday after the stream. I kept writing some documentation for work, and I'm pretty happy with how that documentation looks. We can look at it later. After this Erlang part of the stream, I'll probably do some work again. I actually want to set up my Raspberry Pi that I've been sitting on forever because now I have a purpose for it. I want to like serve the missed pages, missed MD, missed markdown pages that I've been writing with. Um, so that like the documentation I write is available. So I want to host it on a Raspberry Pi, figure out the best way to do that. And I also have to figure out how to port forward to the Pi through, our home router. So that'll be something else to do. So all that coming soon. Let me arrange these windows a little bit here. Let's see. Is this the most important one? Yeah. All right, are we ready to get started? Did I do anything else yesterday? No, I think that was it. All right, let's get started. All right, so here's the book. We've gone through the basics, all of these data types, what modules are, how to do conditionals, type conversions, sort of, recursions, and then we did quicksort and trees. And now we're up to higher order functions. So we're getting there. I can't believe how much more stuff there is, though. Maybe this will be really good to read through all of it. When was this thing made? let's see. Let's say here. Not really. Doesn't have like a copyright. Yeah, I wonder how old it is. Okay, so this is where we start. We're really starting now for today on Erlang. Higher order functions. Let's get functional. An important part of all functional programming languages is the ability to take a function you defined. C'est quoi ce son? Oh, my partner is here today, so you might hear her a little bit. You take a function you define and then pass it as a parameter to another function. This in turn binds that function parameter to a variable which can be used like any other variable within the function. A function that can accept another function's transported around that way is named a higher order function. So a function that takes a function as a parameter is a higher order function. Sometimes I don't remember these things. Higher order functions are powerful means of abstraction and one of the best tools to master in Erlang. Again, this is a concept rooted in mathematics, mainly lambda calculus. I won't go into much detail about lambda calculus because some people have a hard time grasping it and it's a bit out of scope. However, I'll define it briefly as a system where everything is a function, even numbers. Because everything is a function, functions must accept other functions as parameters and can operate on them with even more functions. All right, so that might be a little weird. Let's start with an example. All right, let's okay, this is kind of funny. It's a funny example. Do you think it's better if I make this bigger? Maybe not. Let's see. Higher order functions. Should we do this? This is how we start a module. Higher order. Oh, they wrote higher order funds. Maybe I should do that. Higher order fun dot Erl. Right? The module name has to match the file name just without the Erl. And compile, export all. That means we don't have to continuously add the thing we want to export. Otherwise, we have to do stuff like, what was the other one? Like export every time we write a function. And now we'll define a function called 1 that returns the value 1, a function 2 that defines a function that returns 2, and add that takes in 2 functions, right? So it calls, here we're going to call the function x. What the hell? Plus y. In Erlang, all variables are capital letters. Let's see, why is this not happy here? It's just a warning. Okay, so now that that's there, we should be able to, actually let's keep this running like this. And we'll use this tab for, what was I running? Vice? Oh, that was a while ago. Mist MD. I think I've done that. Projects, Erlang. Here we are. So now we can do Erl. And now we can compile higher order funds. That compiles it. Warning! Yeah, that's fine. So now we can do higher order funds, colon. That's the module like separator. So we have a namespace there. We pass in add. And we got to pass it in x and y. So we give it 2 functions, right? We can give it 2 and 1, for example. Oh, that's not how you do it. Maybe we have to look at this. I see. We have to specify it like this. Right. We need fun HH funds 1 for the namespace 0 to show that it's arity 0. We can do 2 first. It doesn't really matter. And then do fun HH funds 1 0. And there we go. It adds 2 and 1 and gets 3. This is how we... I wouldn't have tried this though. But this one I should have known wouldn't work because it didn't have the namespace operator. It's interesting it needs this fun thing. Yeah, I guess it can't take this. Yeah, it needs the fun. All right. Hey there, Kingo. How are you? Hey, Charlie. How are you? I'm doing good. Trying to wake up, do stuff. Gonna spend about an hour learning and then the rest of the time working. I think the working part is really boring, but I might as well like stream it. It's kind of like working while on Discord or something. You ever do that? I know but when are you ever not tired, Charlie? All right. Uh so yeah, like you see how we pass two functions to add and it's going to call both functions. It doesn't care what it is. So, I can even pass 2 twice, right? And now it's going to tell me 4. Um I Oh, we're going to learn how to do inline functions, but I'm kind of cheating here. I'm looking no. I know I don't know how to do anonymous functions yet. Oh, here they are. We're going to learn here just like this. So I wonder if we can pass an anonymous function here. We do fun. It takes no parameters and then it just returns the number 10, let's say. And then we call end period. So we pass in the to function, which you've seen over here, which just returns 2. But here we're making an anonymous function. Let's see if this works. Ah, crap, it doesn't like it. And I have sound on. Let me remove that. Yeah, we have to learn how to pass these anonymous functions around. Fun, 10, end. It looks like this should work, but I don't know why it's not. Maybe we don't need this end. Oh, there we go. So we passed in the function that already exists from here, and then we made a function sort of dynamically on the fly, and we pass it in here, and then it calls add, ends up calling both functions, you see? X and Y. It doesn't know what they are and just adds them together. So you can imagine passing 2 anonymous functions here. Function, this is anonymous here. And this one returns 20. And now it's going to add 20 and 10. There we go. It's like magic. You haven't gone to bed yet? Oh my god. So when did you wake up last? $11. Yeah, that kind of checks out. You must be starting to get pretty tired. You're on your kitty's schedule, aren't you? All right, where were we? We kind of skipped around. Confusing, not so much once you know how it works. Isn't that always the case? In command 2, this one here, there's two atoms, 1 and 2, that are passed to add, right? We're passing these two parameters. But let's see here. Which then uses both atoms as function names. If function names are written without a parameter list, then those names are interpreted as atoms, and atoms cannot be functions, so the call fails. Basically, it's saying this is busted, right? Because you can't just have an atom here. It doesn't know that it's a function. And 3 fails because 1 and 2 cannot be called as functions either, right? Because it's going to try passing in here, add, and then it's going to call 1. X becomes 1. It kind of looks like this. And that doesn't work. I want to try to hang on as long as I can so I can fix my sleep. Sure, just power through it. Scheduled by fucking it up more until it's good again. You know, this plan rarely works. Like, how many times have I heard it? It almost never works. Let me know if it works for you. Oh yeah, Pum isn't happy with me being awake when she is. She can't do crime. That's hilarious. Okay, so we compiled it. Yeah, we did all this, and then we got it working. Confusing, da-da-da, we did this. This is why a new notation has to be added to the language in order to let you pass functions from outside a module. This is what fun module colon functionality is. You know, for a language that's going to make it like you're passing around functions all the time, like this is way too verbose. Like even this is way too verbose. Where was it? Here, right? Like that's just too much typing to pass two functions in, honestly. So what are the gains of using functions in that manner? Well, a little example might be needed in order to understand it. We'll add a few functions to hfunds, haha funds, that work recursively over a list to add or subtract 1 from each integer of a list. Yeah, it doesn't work a lot, and it only lasts me like 3 to 4 days before it gets worse again. Yep. 100%. All right, so what is this doing? This is an increment function. It takes in a list. And, oh, it increments every element of the list by 1. All right, without looking at that, let's write that function. It's not like it's hard, right? I just wrote, but increment. So takes in a list, adds 1 to each element, and obviously returns that list, right? So think recursively. If the list is empty, then we just return an empty list. Easy peasy, lemon squeezy. And we use semicolon, right, for clauses? I think so. And then we have a list that that's not empty, right? So here's our list that's not empty. So what we'll do is first element is head of this list. Then we have a new first element, which is first element why doesn't it help me? Plus 1. And then we return, we have the rest of the list. Let's call it tail. And that's equal to what? Is there something like tail? I'm not sure. And then that's the rest of the list. Then we construct a new list, which is the new first element. Oh, these all have to be capital. I forgot. Because that's how variables work in Elixir, in Erlang. New first element followed by the tail. Right? And now we just call increment. Oh no, we can't do that. We have to increment everything else in the tail, right? So we do incremented tail is equal to increment tail list. And now we can return new first element plus incremented tail list. Right? Okay, so the thing isn't tail. What do you think it is? TL? Yeah, return the tail. Incremented tail is unused. Oh, that's because there. How's this? How do you guys think of this code? Let's try to compile it. And now I can do h8 funds colon increment, and I give it a list. 1, 2, 3. And I get back 2, 3, 4. Look at that. And obviously if I give it back a single empty list, I get, yeah. So 10, 10, 10. I get back, that's actually a bad example. I'll do 1, 10, 10, 10. If all the characters are printable, if all the elements are printable ASCII, then it's going to make it look like a string. So I put the 1 in the beginning. 1 is not printable, so therefore, that's code all right. Yeah, it looks very codey. Now here's the thing. You're supposed to say, this is super gross code. This is fucking disgusting code. If someone wrote this for me, I will fire them. Assuming you can fire people. Because we're really doing way too much work here, right? But these are the steps. Like if you really break it down, these are the steps. But notice that we can probably rewrite all of this in a much shorter way by doing pattern matching in the front here of the parameter. So even though we're getting past the list, we're going to break it up in the actual parameter. We're going to say we have the head, which is the very first item, and then the rest of it, the list, right? Now, in the function, I think we can just basically return. We're going to construct a new list. We're just going to do h plus 1. So that's basically, oh, my monitor went off. That's basically going to add 1 to the first item of the list. And then for the rest of it, we just call ourselves to it. And we call it t. Right? And this will construct, this should do the same thing. Let's try compiling it. And now if we give it this list, look, it does the same exact thing. Just to show that this is the new code that it's using. What? Why doesn't my monitor come up? Just to show that, hello? I'll do +2, right? And now when I compile this and I run it again, you'll see that everything was added by 2. And so just compare these two functions here. Just remember, like, this is the power. This is the power of pattern matching, where you don't have to break things up into two different lines here. Save it in variables. Then do a work where you're basically adding a new, adding the plus one. You don't have to do all that. This is probably, once you know the language, a lot clearer. So there we go. That is our increment function. So we'll also write the decrement. Um, and subtracts 1. Yeah, I guess that's fine too. Power of friendship. Where's that from, Sherry?
Yu-Gi-Oh?
Yu-Gi-Oh? I was gonna say Winx. I saw Winx Fate Altered. Oh god. And I didn't watch the last episode because before the last episode I found out that it was canceled. And I'm like, there's no way they can resolve it. It's just gonna be shit. So, or is it Altered Fate? I can't remember. But I'm very disappointed. Never gonna watch Winx again. Um, but I just finished well, I watched season 1 of Wednesday, and it's like I don't love it, but it's just kind of easy to watch and fun. So, and it's not emotional. I don't get too attached, so I can kind of just watch it whenever, like if I'm on the train or something like that. So that's kind of nice. And now I'm like basically got 1 or 2 episodes left for season 2, and I think I need a new thing to watch when I'm just bored and can't do anything. Most suggestions coming to me are all like K drama or C drama. It's kind of crazy. I guess it's getting really popular. Oh yeah, and you're watching a lot of K drama. Oh my god. It started with that Parachute series. Like, I'm the worst person to watch a show with because I can watch 10 minutes and then I start getting too emotional or bored and I need a break. and I take it that most people don't do that. So, so yeah, we basically can't watch stuff together. And then she just watched the rest on her own. And it seemed like it took a while. There's probably more than like, I don't know. I have no idea how many episodes there are of that Korean K-drama Parachute movie show.
16.
How many?
16.
Wait, you took that long to watch 16 episodes?
I took my time. I watched another series in a weekend.
All right, we're getting distracted. All right. So, how do you think decrement's going to work? It's going to work the exact same way. If it's an empty list, we don't have to do anything. Otherwise, we're going to break up the list inside the pattern matching for the parameter, and then we're going to reconstruct it and do h minus 1 for the head, and then just call decrement. This is recursion on the tail. How beautiful is that? Right? You know, I was just thinking that like decrement could be written as a list comprehension, right? Like, look, decrement some list, right? And then we just make a list. Here's list comprehension where we do n minus 1, and n is each letter in L. I think that's it. I literally think that's it. Fuck. Syntax error. I think it's 2. There we go. Let's try compiling this and see if it works. Okay. HH funds decrement, and I'm going to give it a list. 10, 9, 20. 9, 8, 19. Isn't that so nice to use something we've learned? But that's not what they want. We're gonna do the we're gonna do the kind of vanilla way here with recursion. Yeah, I get it. Sometimes I just scroll TikToks and but right now on my YouTube, I don't know if I like really fucked up my algorithm, but basically nothing looks interesting anymore. Like zero. And I know there's interesting stuff because people send me stuff, right? And I'm like, that's really cool. Why doesn't my YouTube have that? No, it has garbage. What is this? Being bullied and recovery, are you okay? Okay. France 24, Nicolas Sarkozy, déclaré coupable. So this this ex-French president keeps like the news is constantly that he's going to jail, but I never see him in jail. So, I don't believe it's real. Some classical music played from sheet music. BBC breaking news, Huntington's disease successfully treated. Well, that's good news, but I don't really want to watch that. Some AI news. Why facts don't change minds. That actually sounds kind of interesting, but I'm not going to watch it. Yeah, you see, like, I don't know. And where's all the cat videos? Pink Pony Club cover by Rick Astley. Astley. Well, guys, that's kind of the first comments. We've been Rick Roaned. No, I checked if restricted mode was on. It's not on. There was like a whole bunch of like things saying like go check that. I checked it right away. It's not on. I just have it just went to shit all of a sudden. And every now and then TikTok is just giving me ads, like nonstop ads. Okay, where are we? We made decrement. We did the same thing. They're doing the same thing. They pretty much just take in a plus or a minus, right? So when you look at these two functions, you could basically rewrite it just by changing the plus and the minus. See how similar these functions are? They basically do the same thing. They cycle through a list, apply a function on each element, and then call themselves again. There's almost nothing changing in that code. Only the applied function and the recursive call are different. Yeah, the recursive call in the sense that the names are different. The core of a recursive call on a list like that is always the same. We'll abstract all the similar parts into a single function map that will take another function as an argument. Look at that. Okay, let's not look. Let's try to write map. So the idea of map takes in a list and a function with just the function takes in element of the list and runs and returns a value. Map itself, map will run the passed in function for each of the elements in the list and return the new transformed list. Okay, so the algo is so asked most times, like it just removes all of your interest and shows you your new account stuff. It feels no, seriously, YouTube is one of those things where, like, if I watch one wrong video, it's like, this is what you like now. This is you. This is, and everything. It has no memory of what I liked ever before. Yeah, God forbid I want to see something I was interested in a month ago, you know? Anyway, so map. We take in a function. If this list is empty, then obviously we're done, right? I feel like I'm gonna need 3 parameters, but I'm not sure why. Um, yeah, so if we have the empty list, we're done. This was how our other one was. But if our list has stuff left, fn is our function, right? In case that wasn't clear. That would have been plus or minus in another case. Um, Now we're going to call the function. Maybe we need to do fun. What was, how did I write that before? Fun. Yeah, we're going to have to look at the syntax for this, but let's assume we can do something like, I wonder if we're going to have to do like this. No, it doesn't like it. Anyway, maybe for now we'll just remove all of this and we'll see what happens. So we call function on the element, which is the head, and then we're going to call map on the rest of the list. There we go. And we have to pass our function again. And function doesn't matter here, so we put underscore. Let's see if this works. So now we'll compile. Oops. Huns. Now I can do map, and I pass in a list, and I pass in a function. Function, add 1. How do we do the anonymous function? Yeah, it looks like this. There we go. It did not like it. Let's see how well we can kind of cheat and give ourselves a function. Add 1. It takes in an element. X. Oh, maybe I didn't capitalize it. Yeah, maybe that's what it was. Let's look. Yeah. Nope, that wasn't it. Add 1, that returns x plus 1. Okay, let's see if we can just use that function. So we do funds, add 1. I think like this. There we go, that worked. So you notice that it returned a list 2, 3, 4 from our 1, 2, 3. And how did that work? It basically used our function here. I explained it while I was typing it, right? Um, and then what I did was I made it easier so I can pass this function in here. I just don't know how to do it. I don't know how to do it dynamically. That's what I don't get. Like, why didn't that work? Function. Oh, did I just need to do this? Oops. Or maybe it's just like this? Uh, there it is. I figured it out. So, I can pass in a dynamic function here. So now you see I can even write -1 and it subtracts 1 on all of them. I'm just giving it a function. And I can even write where I multiply each element by 2. There it is. Or what's interesting is I can add 64 to it and it will turn it to ABC. Don't believe me? ABC. That's because when I add 64 to this letter, it turns this to 65, and 65 is capital A in ASCII. And since it sees ASCII characters, it prints it as a string. How nerdy and geeky is that? It's pretty fucking geeky. Like, you do these kind of things on an interview, they should hire you because they're like, you're so fucking nerdy. You have to be good. You're just gonna know. Well, you might be very annoying too, though. And I'll admit I can be slightly annoying. Oh my god, we're like in the we've gone nowhere. Holy shit. No, we have, right? We're here. Okay, guys, we're going to have to speed it up. I think we've done all of this already. What? Oh, I see. That's pretty cool. But don't worry about it. We're just going to skip linked list of characters. Ew. Is it a linked list? Yes, it's sort of a linked list. It's not really a linked list, I don't think. I think it's a list. It's like an array. You're probably right. I think it is some sort of linked list because it can grow, it can get smaller, so all the elements are separate. All right, anonymous functions. We already sort of learned this already because we made an anonymous function here. Um, this is just saying you can have your expressions separated by commas. And that's kind of what we did earlier on when I had that really long version of the function. Let's see, what are they doing here? They're making a function that just returns the atom A. And then when you call the function, it returns A. So now they're going to map. Here's the map function. We're passing in the +1 operator in L. That's exactly what we did here. And the nice thing that works there is just like um, we can pass any length of a list, right? And now you're seeing one of the main things that make people like functional programming so much, the ability to make abstractions on a very low level of code. Basic concepts such as looping can thus be ignored, letting you focus on what is done rather than how to do it. Anonymous functions are already pretty dandy. It's so dandy for such abstractions, but they still have more hidden powers. Yeah, you just have to be nerdy when you go for an interview. Prepare alarm function room. So here we have an anonymous function. It's going to say alarm set in this room. Function IO format alarm tripped in call Batman. I see tripped in room. Here's the room. Alarm ready. Prepare alarm bathroom. Alarm set in bathroom. Alarm ready. Alarm tripped in bathroom. Call Batman. Interesting what's going on here, right? So here, this prepared alarm stuff, let's type it in, might as well. Prepare alarm is equal to function room. So now prepare alarm is this function. And it's going to print out, when you run this function, it's going to say alarm set in, and then this S will look for the first thing in this list and print it out. So it's going to say alarm set in room, and room is whatever room you pass in. Something's and the second line of this function is actually an anonymous function, right? This anonymous function is saying alarm. When you run this anonymous function, it'll say alarm tripped in, and it'll say the room. Oops, it didn't finish here. Call Batman. And here we're going to pass in room also. Okay. I guess you can format it maybe this way. Let's see how it does it. Okay, it likes it this way. So, syntax error before prepare alarm. Why? I think it's probably because we're trying to set a variable inside of a module and it doesn't like that. So let's ignore it. We're just going to copy and run this in the Erl REPL. Oh, wait, why is this like period so far away? Oh, it wants to do that. I don't know why. That's so weird. All right, let's see if we can run this in the other REPL. Yeah, it ran it. So prepare alarm is a function, right? So that's what we expected. Now, when we run the function, we have to pass it a room. So let's give it a room. What's a room? The foyer. So it says alarm set in foyer. But notice that we saw this at the end. That's because this running this function actually returns you a function, right? Since it's the last thing it evaluates, it's going to return this. So let's capture this. So we say they call it alarm ready. So now alarm ready is a function too. See? And now if I run alarm ready, it's going to run this function, alarm tripped. This function takes no arguments, you see here. Alarm tripped in foyer, call Batman. The interesting thing is that this function, even though it takes no parameters, had a concept of what room it was in, right? So in a way, this is not a pure function. This is called a closure because it's getting stuff from outside of it and using it. Hold the phone, Batman. What's going on here? Well, first of all, we declare an anonymous function assigned to prepare alarm. That's here. The function has not run yet. It only gets executed when prepare alarm bathroom is called. Right, because just assigning it doesn't call this function. It just returns a function that you can call later. At that point, the call to IO format is evaluated, alarm set, text is output. The second expression, another anonymous function, is returned to the caller and then assigned to alarm ready. So here we're actually assigning it to alarm ready when we call prepare alarm bathroom. So alarm ready knows about bathroom, right? Because this function here is what it's pointing to, and in here it knows about room. And note that this function, note that in this function, the variable room's value is taken from the parent function prepare alarm. This is related to a concept called closures. To understand closures, one must first understand scope. A function's scope can be imagined as the place where all the variables and all their values are stored. In the function base A, B is pattern matched to A plus 1. A and B are both defined to be part of base's scope. This means that anywhere inside base, you can refer to A and B and expect a value to be bound to them. And when I say anywhere, I ain't kidding, kid. This includes anonymous functions too. So here's the base function where we have B, but then we define a new function where we use A and B and we return that function. So now when we call F, it's able to multiply A and B together, even though all you were passing in was A initially. Okay. Um, I won't kill, I won't like, what's it called? Beat a dead horse. A lot of this is saying the same thing. If you don't understand, let me know. Send me a comment, whatever, and we can go over it some more. But this looks pretty straightforward to me. Secret Pony. We're just talking about Chapel Roan. How funny. Um, Whatever. You're most likely to use anonymous functions to carry state around when you have functions defined that take many arguments, but you have a constant one. Math pow, so raising 5 to the second power, so it's 5 squared, which is 25, right? Base is equal to 2, power of 2 equals function x math pow base x end. This is like really boring me. Yeah, I don't get it. Power of 2 is just simplifying pow so that you don't have to call um pow comma 2, you just do power of 2. that raises automatically the function to the value to the power of 2, and we call map, so it's going to be 1 squared, 2 squared, 3 squared, 4 squared. We get it. Sometimes a little trap you might fall into when writing anonymous functions when you try to redefine the scope. Ya la la. Okay, let's just get to here. We'll get to here and then we'll pause a sec. Base a equals 1. So this is a function that takes no parameters, right? A equals 1. Fun. A equals 2. Whoa. But A's 1. So this function is anonymous. A equals 2, which should kind of return the number 2 if this was on its own. And then it kind of ends up executing itself, so it should return 2. This will declare an anonymous function and then run it. As the anonymous function inherits base's scope, trying to use the equal operator compares 2 with the variable a bound to 1. This is guaranteed to fail. However, it is possible to redefine the variable if it's done in the nested function's head. Ah, we're passing. Yeah. This is basically from lambda calculus. This value argument to this function is not the same, even though they look the same, because the head is different. And this works. If you try to compile it, you will get a warning about shadowing because you're covering up. You can't access A anymore in here, not the 1. All right. So there's some kind of trick where you can like, what? Do something with a name? Why is this so fatiguing? What is this saying? Can someone tell me? I'm just so the loop variable refers to the anonymous function itself. Oh, does it? All right. Okay. Makes you wonder why they need to do this, right? Maps, filters, folds, and more. So we wrote map. We already did this, right? Then we have this code. Map. Except we put the function second, they put it first. Can't remember what's... Or like on the Go recursive functions for looping. However, there are many other similar abstractions. Even. What? Only keep even numbers. Okay, but isn't that like just we've already done this, right? Why can't I? Why is my helix not working anymore? So even we pass in a list. If it's empty, we do empty. Otherwise, we have it's always the same, right? Head and tail. And now how do you say mod? Is it remainder? Right? So there we go. I think it's semicolon. La 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 la. Event. All right. HH fun. Haha fun. Even. 1, 2, 3, 4, 5, 6. 2, 4, 6. Huzzah. Um, so even on an empty list is always empty. We pattern match, so we break it down and we check with a guard if the first element is even. And if it is, then we include H and then call even on the rest. Otherwise, we don't care about the first one because we know it's not even, in which case we ignore it and we just return the rest of the list. In the context of what we're trying to do here, what is going on, we could make this a map function, right? We want the context of higher order functions, right? So actually, let's do it like this here. Hans map, and it took in the function first, right? So I think the hardest thing for me to remember is the function syntax. So here's like x, which is an element of the list. And then it's going to basically be a predicate function. So it says true or false. Map is funny because we cannot easily filter stuff. We really need like a filter or a reduce function, right? Because map's just going to, it can't change the number of elements in a list. Well, what we can do is apply the whole function in here. So it would be hahan even, which takes in 1. So I think we do this, right? To say this is the function we're passing. And then we pass in the list. And that did not work. Why? No function clause matching, even. Even takes in a list. Map's going to take in an element. Why doesn't that work? Oh, it takes a list and the function. I'm passing it backwards. All right, take it easy, Charlie. I hope you sleep well. There we go. So you see here, we've passed map, we've passed in a function even, and we gave it a list. Unfortunately, we can't pass it a regular list like this. It needs to be wrapped in a second list because map is always going to call this function for each element in the list, and it even needs a list. So I had to wrap it twice. And then you could basically call head on this, and you get back the actual number. So this is like a total like bullshit like way around it, but in order to use higher order functions. But what we really want is a reduce or a filter. I think reduce and filter are the same thing, and we'll probably see this in a second. So, yeah, this is exactly the function that I wrote earlier. Only keep men older than 60. This is like the anti-Logan Run. Have you guys heard of Logan Run? It's like a old sci-fi movie where anyone over 30 voluntarily goes into this carousel party dance nightclub and kills himself. Oops, I probably can't say that. I'm so tired, Sherry. I want a nap. I want a nap with Charlie. It's Charlie. We haven't seen Charlie in a while. She says hi, Charlie, if you're still there. You're not in, Charlie. Elle a dit bonjour. Bonjour. Oh, we should hang out sometime soon. You know what's funny, Charlie? I was like streaming and I'm gonna do a talk in Berlin in next well, no, in November. It's not next month yet. A few more days. And someone the talk's in Berlin and the person watching the stream said something about how they're from Bavaria. And I was like, "Oh, are you gonna go to the Elixir con?" And they're like, "Yes." And I'm like, "Oh, we're gonna meet up there then." So that's kind of like what chances? All right, what's this code doing? Reverse list the person. I'm I see. They're gonna define this. Okay. I'm in Paris start of October to plan my new tattoo. Yeah, let's meet up for lunch. I actually want a tattoo and I want a new piercing. I think on my left ear because I only have one there. I have two here already. So I want to add one piercing on the left ear and probably the tattoo shop you're going to will do piercings. So definitely let's plan that out. Yeah, you know the other problem I have, and maybe you know something about this, like on this ear, I kept getting infections on my first piercing, and so I found out like I'm just really allergic to metals. Um, and I switched to just like 18 karat gold loop or something like that, and now it's fine. But this year never has problems with metals. So I don't understand why this one has problems with metals, but this one doesn't. So how do I and then I it feels like when I searched for like, whatever you get, titanium or like high carat, like solid gold, not like just plated. Well, it was surgical steel. Turns out that surgical steel isn't always fully allergen free. There's different grades of surgical steel, and even like some of it, like I had surgical steel supposedly, and it was not good enough. I have to like I saw my allergist and she's like, "No, you can't use surgical steel. you are at the point where you need to get gold or titanium, or there's one other. What's the other one, Cherie? Gold, titanium, and something else.
Silver?
No, no, not silver.
Oh.
But I don't know how much like in France I can find those things, but maybe Kraken will do that. All right, but anyway, let's chat. We'll figure out. I do one side at a time too because of the sleeping thing. Maybe you're right. Maybe I should do double and get like a helix one also. Because if you're gonna like not sleep on a side for a little bit, might as well like go go all out, right? All right, let's write filter. I don't know what they're trying to do with the old men thing here, but let's write filter. Let's see. Did they write the predicate on the second statement? No, first. All right, so it's in the shape of predicate followed by list. All right. Well, how long does it take to heal a helix? I really hope it's not that bad. Time flies, you know? 6 months will go by quickly. Yeah, fast forward life for 6 months. Mm. I remember how case statements look like. All right, so we have a filter, which means if we're going to pass in a function p predicate, and we're going to apply it to each element, and whenever that predicate returns true, predicate only returns true or false, and for every element it returns true for, we keep it in the list, and every element it doesn't return true for, we remove it. So that's how that will work. So take it easy, Charlie. I will see you later. Sleep well. So I think I want to use a case statement here. So we pass in a function here, case p of h, right? Of, and then if it's true, we do this, and if it's false, we do this, and then end. Easy peasy. We could have made this an if statement, but we're not going to bother. um, I don't think we can make this a guard because can't call functions in guards. So you see we called p of h. If it's true, it means we want to keep it, right? So we're going to return um, the list including h, and we're going to call filter on the rest of it. Oh shit, yeah, semicolon. Otherwise, we're just going to call filter t and return that. All right, we have to pass in the predicate. There we go. Let's see if this compiles. Oh, it doesn't like P because we're not using it here. Okay. So we do HH_funds filter. Now we give it a predicate. Um, so it looks like we pass in an element and we do xrem2 is equal to 0 end. That's our anonymous function. If it looks familiar to you, that's basically is even, right? And now we pass in our list. Almost. Where did I do this wrong? I think we should be able to do this.
Hmm.
Case P of H. When I ran it, it said exception error, no function clause matching function list. Function list. Oh, it's because I had a comma in here. This needs to be the list pattern match. Oops. There we go. Now you can see it only kept the even numbers and it removed the other elements from the list. And obviously I can keep, I can put a whole bunch of numbers everywhere and it will still work. So that's the filter 1. And they made something called like people, right? Like look at this here. So now we have a list, male, female. This book's so freaking gender oriented. At least they have unknown or non-binary. What is it? And so let's write a filter using our filter command where we only keep, let's keep people who are over 60, right? So here's function. We take in an x. We return. If we were just return true, just to be like really simple, right? And then we pass in the list people, we get back everyone, right? Because it returns true no matter what x is. And now, but here, let's deconstruct x because we know it's a tuple. It's going to be gender, comma, age. And variables need to be uppercase. And then so our thing is going to be age is greater than 60. I didn't match here. There. I didn't match here. There. There we go. Here, let's clear it out so it's a little easier to see. Filter function, it takes in one parameter that is a tuple, gender and age. And then we say true if its age is greater than 60. This is going to return true, otherwise it's going to return false, right? So now we have all the people that are greater than 60. Now, if we also want to say they're greater than 60 and gender is equal to male. It doesn't like that. Why are we not happy? There we go. Just needed like parentheses so that it doesn't do 60 and, like it needs to do this and then run and. So I just put parentheses in there. So now we have only males that are above 60. And yeah, we can go as complex as we want here. Uh, they have and also, they have other keywords. Find the maximum of a list, minimum of a list, sum of a list. Aha, this is where we do folds because you see like we're going through the whole list. Let's write max. Max of an empty list is obviously going, what is the max of an empty list? Let's assume that, let's assume you can't have max of an empty list. We'll hide that away, right? um, so max, we'll make a max helper. And that basically calls the list followed by the highest so far. So we'll call it like, let's just call it M for max so far, right? Or let's call it ACK. So now we have to write max helper. And so it takes in a list which has, if it's an empty list, then we're just going to return the helper, the max we've seen so far. Otherwise, we're going to break it up. And we're going to check, I guess we can put this in the guard. When h is greater than than the max so far, then we're going to call max helper with t because it's the rest of it, and the new in h as the max so far. Otherwise, we don't care about the head. We only care about the tail. We're going to call max helper with the tail followed by the max so far. So the difference is that we've switched what's the max so far in this case. What happened here? Why is okay? All right. Does this look right to you? Looks right to me. We got to pass in a value. So why don't we call head L just to give it the first item, I guess, to start it off. And then we can add a when length L is greater than 0. fun max, and we're going to pass in a list and it found 100. And if we give it a list of 1, it's 1. And if we get an empty list, it says there's no function clause matching that because we specifically disallowed it in this guard. Does that look right? Yep. So if you look at sum, it's kind of doing something similar. Let's see. Sum L is equal to sum L0 because it's saying like there's a sum with a 0. Should we write this? Maybe we should write it. All right, so summing something like a list, right? The sum, like you could kind of just do it how we always do things. Sum of an empty list obviously is 0. Sum of a list otherwise is equal to sum list comma 0. So this is a lot like the ACC that I was keeping here, right? This is like sum 2. You could write it like this. Oops, no. This is like this. But functions with different arity, number of parameters, are different functions, so we don't have to say sum 2. In the same way, we didn't need to do max helper. We could have just called it max. All right, so where are we? So now we're going to write this version, sum, where we're passed in an empty list. We're just going to return the answer so far. Otherwise, it is broken up to head and tail. So then we're going to return head plus accumulator, right? Plus sum of tail, comma. Oh, no, 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 no. There. So this is saying we're going to run sum on just a tail, right? Because the idea when you do recursion is you start with something bigger and you keep going to a simpler case until eventually we run into the empty list, right? So we're going to keep popping out the first element of the list, and then we're going to keep a running accumulator of the current sum. So now that we've popped off the h, we're going to do accumulator plus h. And then at the end, when that number keeps getting bigger and bigger, it's going to return just the accumulator, but by then it'll have added all of it. So let's see if this is, oh, it doesn't like this. There we go. This needs a period because this is the end of the sum/1 version, and this is the sum/2 version. Let us compile this. And now we can run sum, and we pass in a list. And it's 16, right? And just one element, does it work? 0 elements, does it work? So there we go. So there's some. A subtle element of all three function that wasn't mentioned yet is every function needs to have an initial value to start counting with. In the case of sum 2, we use 0. Oh, what did they do with max? Did they use yeah, they used the head also. That's a smart way of doing it. I kind of called head, but I could have just broken it up. Yeah, now I can't do this. I can do this. This is basically saying list is equal to this pattern matched list. So this L will still work, but now I can just do max helper, the new list, tail, right? Because, and here we do head. We're assuming that head is the maximum now. We might as well put this down here. Right? Is that easier to read? I don't know if that's easier to read. We can just change all these max helpers to max. What? Why didn't that work? Oh, because it's calling the other max. There's a built-in max that it's calling the same thing. There we go. My max. Oh, we're almost done. I can't even remember what I was doing. Where is everyone today? Usually there's other people watching. I'm bored. Because I'm wearing my kitty shirt. No one's here because I'm wearing my kitty shirt.
I don't think it's the reason. No one's here because you stream in the middle of the day.
No, usually there's other people here. Maybe Charlie's still here. I don't know, but like.
Wes is sleeping or getting up.
But there's usually other people. I think I'm just boring. That's okay. Would I watch myself, someone like me? I don't think so. Yikes. We're not gonna think too much and introspect here, right? It's generally not a good idea. Let's play video games instead. I stopped streaming to Kick because everyone from Kick was horrible. Like, not a single nice person from Kick. Not surprising, right? I want to set up LinkedIn because LinkedIn people like boring stuff, right? And I'm boring. What do you think? I was looking at the YouTube stats. My most popular videos are Nix and Atari, and like those are the two things I'm not doing right now. If you're expecting Nix and Atari, leave a comment, engage, and then like I will do more. Ah, someone likes it. Just kidding. Oh, Charlie sent me the tattoo. Us. I want like the smallest tattoo first because I was so stuck on like what should the first tattoo be. But then someone at I think it was the local first conference I went to in Berlin, they were like, here's the secret. Just like maybe it was mauve. They were like, just put a small one where no one will see it. And then you'll have done the first one. The rest are easy. So I'm trying that out. And then soon I'll just be like all covered with tattoos. Did you see this is like the kind of tattoo Charlie wants? That is a lot of work. Whew. I wonder how much it hurts. Um, where were we? Were we here? I'm so sorry, guys. I'm like the most. I'm so scatterbrained today. Holy shit. Um, yeah, let's just ignore all of this. Okay, let's just write our own fold. So we want something that acts like these things, right? So fold. Basically, fold's gonna take a list of some sort, some function. And the other ones, was it the function that's first? Filter, yeah, it takes the function first. So let's say we take the function first, the list, and then the accumulator, which is basically where you're holding the work in progress, right? And what's the shape of the function? So fold is going to uh, go through each item element of the list. It will run function on each element and pass in to the function, and function returns the new accumulator, right? So that means that the function's going to look like it takes in the element, comma accumulator, and it's going to return the accumulator. That's what it's going to look like. All right, so let's start writing this. And then when it has nothing left to do in the list, then we're done. So, hello. So basically, if the list is empty, we're going to return the accumulator, right? That's our base case, in which case function doesn't really matter. Otherwise, we have the function, and we have a head and a tail, and we have our accumulator. Now we're going to call function, and we said we pass in the element, which is head. We pass in accumulator. And now we're going to call fold on, it's going to return us the new accumulator, right? So we still have to pass in function, tail, up, and this. Does this make sense? So we've broken it up here, just like we're very good recursive students. The next fold we call the next fold we call will be smaller until we eventually get to the base case. So we don't have to worry about infinite recursion. The new accumulator is going to be based on calling our function with the first element and the current accumulator, and we use that value as the new accumulator. I think that sounds about right. So let's try compiling this. And now we should be able to call fold, and we pass in a function like the sum function, right? So function, and then it's going to be passed in an element followed by an accumulator. We'll do it like this. And it's just going to return x plus accumulator, right? Because this is the sum function. End. And now fold needs the list, and it needs the starting accumulator. So we'll make it 0. 6. Look at that. So if we do this, it's 16. And if we start with that, it's 0. So how would we write max in the same way? Max. We do if x is greater than accumulator, then what's the syntax for if? I think I did it here too, right? Yeah, if something like this. Where'd I go? Oh no, I'm here. If, then we return x. Let's look up. I gotta look up if statements again. Where was that? Maybe here? Here it is. If n, da 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 da, if true. Here we go. Semicolon. So we say this one. The other one is, we just return accumulator. There we go. And then how do we end? We do end. God, that looks ugly, right? End. So if x is greater than the accumulator, then we return x. Otherwise, return the accumulator 3. Yeah, 3 is the max. So let's do 10, 1, 3, 9. It returns 10. Yeah, the default max here should probably be 1 or something like that, right? But we've written our function. End to end. Seriously, guys? That's ugly, right? Anyway, I think we wrote fold. That sure looks different from what I did, huh? Their list is at the end. That's why. This one is the max function. I like how their anonymous function, they actually put in guards in here. That's really cool. What's funny is that you can represent an accumulator as a single element or single variable, and the accumulator can be a list. Therefore, you can use fold to build a list. This means fold is universal in the sense that you can implement pretty much any recursive function on a list with a fold, even map, and filter. All right, so they're implementing map, whatever. Well, I'm not gonna do it. Map, filter, and folds are only one of many abstractions over lists provided by Erlang standard library. We have lists, we have maps, filter, fold, fold left, fold right. Other functions include all or and any, which both take a predicate and test if all elements return true or if at least one of them returns true, respectively. Then you have drop while that will ignore elements of a list until it finds one that fits. So there's lots of functions, and we can probably look at all of that. A complementary function to the two previous ones is partition, which takes a list and returns two, one that has the terms which satisfy a given predicate, and one list for the others. So it's kind of like filter, but it gives you the garbage list also. Other frequently used list functions include flatten, flat length, flat map, merge, nth tail, split, and a bunch of others. You'll also find other functions such as zippers, unzippers, combinations of maps and folds, etc. I encourage you to read the documentation on lists to see what can be done. You'll find yourself rarely needing to write recursive functions by using what's already been abstracted away by smart people. Excellent. Oh, I love the picture. So we're done. We're done with not everything, but we're done with higher order functions. Do you feel like you are higher order function masters? Why is this higher order person French? Lambda? That's not French. Sure looks. Does this guy look French to you, Chérie? No? Oh, maybe it's just me. It just looks like a caricature of a French person. No baguette, so not French. All right, so we'll do errors and exceptions next session. How long have we been working? An hour and 50. Oh my god, I am so slow. But, someone said I posted a video on like not enjoying program. You can see like I'm trying to have fun while learning, which means I'm not all just like try hard lock in and get to the end as fast as possible. It's also about like enjoying the journey. And I finished my tea, so now's a good time to break. I'm going to make more tea and then go work. I'm gonna stream work for a while. I think I have my first meeting in an hour and a half. It's starting to get chilly. Oh no, I have more than an hour and a half. 1, 2, 3 hours, maybe. so thanks for hanging out. If you're watching this later, hopefully I have the information for Erlang, like, the book, all that kind of stuff in the description. I will change the name now because we're gonna go do work. Doing some work. Working programming stream. I think that changes it. All right, so I'm gonna go break. I will talk to you later. I mean, I'll be back. I'm not stopping the stream right now, but just going to break for a bit.